Recorded is rolling. It is Monday, April 20th. We're on to lesson 11.3 multiplying matrices. I'll do these examples with you guys, and then here I printed out you guys this packet, and I circled the ones I want you guys to do on your own independent practice. Okay, so these right here. Okay. And this packet is 11.3, but also 11.4. So the next page 2 is a 11.4 question, which I'll cover with you guys tomorrow. Okay, so you guys go with that so far? Okay. And then this note here, and pass back all your papers. I think your quiz I got to you last Thursday, I think, but everything else, all right, these notes, but not everything's been returned to your folder. So if you want any old papers, those are there. All right, so when you multiply a matrix by a matrix, it does get a little tricky. And there's a little trick to it. Now, last week you guys were multiplying scalar quantities, so you could multiply an entire matrix by 4 or something. Just multiply all the elements by 4. But when you multiply a matrix by matrix, it's a little different. All right, so I'm gonna give you guys a kind of a hold on, computer's freezing up. Sorry. What is going on? Here we go. A practical example of matrix multiplication. Okay, so this is a pretty simple example, but I think it's a good visual. Is what if you're trying to turn this nut with this wrench? Now, guys, if you had a longer wrench, you guys see this R for like radial size. What if you had a longer handle? Would that be easier to turn that nut?
Yeah.
Yeah. What if you press with a harder force? You guys see F for force? What if you press with a harder force? That'll also make it more likely. And one more detail. You guys see this blue angle theta right here? Angle theta? Ideally, you want this angle to be what? How many degrees? Huh? 90. Guys, if this is 90 degrees. Because what if that angle was 0 degrees? Wouldn't there be no rotation at all? Right? Or if you like, could you replace the nut and the wrench with maybe a door hinge and a door? Ooh. You guys ever wonder why is the door handle opposite of the hinges? Why not put the handle like right next to the hinges? Because that would be really hard to open the door, wouldn't it? Right? So the physics property here is called torque. And it involves a special kind of multiplication called cross multiplication, which is also involved with multiplying matrices together. So you could represent the length of the handle as one matrix. Maybe it could be like some simple matrix. Right? And you could represent the force with another matrix, and then you want to multiply these together. Okay? And it turns out that this angle also matters. Okay? Now, interestingly, with the cross product, cross multiplication is not commutative. So if you do R cross F as it's shown, if you instead multiply F cross R, you get a different like magnitude answer. Like it might show up as negative instead of positive for this very simple case. But for more complex matrices, you get an entire like a different answer altogether. Okay, so if that helps to have that visual in mind. Okay, now when we're multiplying matrices, you guys remember matrices have different numbers of rows and columns. So here I got a 2 by 2 matrix and another 2 by 2 matrix. You guys see 2 by 2 times a 2 by 2. Okay. Well, the number of rows and then columns, then rows and columns. The number of columns from the first matrix have to match the number of rows from the second matrix to even be able to multiply these together. So can you multiply a 2 by 2 and a 2 by 2? Yeah. Right. Can you multiply a 4 by 1 and a 1 by 4? Yes, because these fours would match. Right? And then these outside numbers represent the dimensions of the product of those two matrices. Right? So as we do more examples, that'll make more sense. Okay, you'll see that. Okay, yeah, I'm just gonna flip through the ones I wanted to do with you guys anyway. Okay, so I was gonna do with you guys, looks like 5, 7, 9, and 16. I think I should cover any questions you guys get related to these. Do 5, 7, 9, and then eventually, a story question right here. Okay, so we'll do all 4 of those. Okay, so number 5. I got a 2 by 2 and a 2 by 2 that I'm multiplying together. Okay. So number 5. I got -10, 7, -2, -1. Okay. Now your book they put a little dot there for multiplication. I'm gonna probably go with that little cross product right there. Okay, so that's a cross product because really that's what this is. Special kind of multiplication. If you go to college and you get like high level math and science, they'll probably put little cross products there. Okay, something like this. Okay. Okay, so how do you multiply a matrix times a matrix? Okay. So what it ends up being is all right. You go across the row on the first matrix and down the column on the second matrix. You guys see that? See how I'm moving my fingers here? Across the row here and down the row here. Okay. So, guys, Oh, here, I'll write this out. Negative 10 times 2. Okay. And I'll take plus and do 7 times 9. So plus 7 times 9. Okay. You see that? I did that. Okay. Okay. And then that represents the first element of the answer. Okay. How about this top right element right here? Element 2. All right. So here I'm gonna go over to the second column. Okay. See, it's kind of like the intersection of the top row and the right column. Right. We'll give you top row, right column. Okay. So I've got negative 10 times 5. Okay. And then plus 7 times 3. Okay. Okay. And that'll be this top right element. Okay. Now the bottom left element, I have to go the bottom row here and the left column here. Okay. So that's negative 2 times 2. And then plus negative 1 times 9. Okay. And then for this last element, I have to do, you can probably figure this out. Okay. Would it be this row and this column right here? Okay. So negative 2 times 5 plus negative 1 times 3. Okay. Of course, these are all actual numerical values. So let's clean this up in a calculator and see what that actually comes out to. But it is negative 10 times 2 plus 7 times 9. So this works out to be 43. 10 times 5 plus 7 times 3. Negative 29. 2 times 2 minus 1 by 9. Negative 13. Negative 2 times 5. And also negative 13. Okay. And that is the answer. That is the product of those two matrices. Okay. If this were like some radial value and some force value, then that could represent the torque. Right? How much like turning moment did you put on that nut with a wrench?
That's freaking out.
Right.
Just
okay.
Yeah.
Okay, so multiplying matrices. Okay, so you guys got that? Okay. Let's write it down. Oh, groups. I meant to. Here. You guys know how many guys keep these notes for points, right? Okay, so you guys wrote your name on your paper. Okay. This is 11. 3 notes.
Yes.
Okay. Okay. So you guys get your name on your paper, 11 3 notes. That's one example right there. You know what? Get your catch up on that. I'll show you guys a really generic version of a 2x2 times a 2x2. Would have had A, B, C, D, and I'm cross multiplying E, F, G, H, or something like that.
A, B, C, D, E.
So this is the same thing we just did. This is if you need extra notes or if you want to see this really generally written out.
No.
Instead of being A, E, B, G, I got A, F, B, H. I got C, E, D, G. And then finally C, F, D, H. Yeah. Same thing. Same thing. Oh, effort completion 2. Here, go back and make another note here. Guys, this is a 2x2 matrix and times another 2x2 matrix. So the fact that this number column matches this number rows means you are allowed to multiply it. And then these outside values, this 2 and this 2, tells you the dimensions of the product. So yes, it also ended up being a 2x2 matrix itself. All right, you guys ready for next one? No, not yet. All right, now. All right, let's go. Next one is number 7. Okay, number 7 for the packet. Oh, this is interesting. I got a 1x3 matrix in a 3x2. Do you guys think you can multiply that together? All right, let's try it out. So I got 1, 3, 0. So again, that is a 1x3 matrix. And then I'm multiplying by, okay, got 6, negative 2, 2, 3, 7, 3. I got a 3 by 2 matrix. Okay, so 1 by 3 times the 3 by 2. What's that? Actually, guys, this 3, that matches that 3. That means, are you allowed to multiply these?
Yeah.
Yeah, you sure can. Okay. And the product is going to be a what by what matrix? Huh? Okay. So this matches this. So matches, therefore can multiply. Okay. And the product is going to be a what by what? Yeah, a 1 by 2. A 1 by 2 matrix. Okay, so we multiply these two together, we're going to get an answer that's a 1 by 2 matrix. Okay. Okay. Although there are a lot of numbers, so there might be a lot involved with this. Okay. So I'm going to go across this row, which there's only one row. Oh, okay. And then go down this column, and I'm going to add these 3 different products together. You guys ready to do that?
Wait, yeah.
Okay. So let's go 1 by 6 plus 3 by 2 plus 0 by 7. Okay, that's the first element.
Heck yeah, yo.
And then, all right, start over this. Okay, same row, but there's only one row here. Okay. But now the second column, ooh, that's different. So 1 times negative 2 plus 3 by 3 plus 0 by 3. Okay, I'll go clean this up. So got 2 elements in the product. So this looks like 6 plus 6. That would have to be 12, I think, right? 12? And then, okay. And then over here, I got negative 2 and 9. So that comes out to what, 7? Yeah, 12, 7. So the answer is 12, 7.
Freaking orange. You said that wrong. That's the real color. Let's think. You might be happy you grabbed I think that's great book.
All right, you guys got that? Well, all right, number 9. Ooh, this guy's got a 3 by 2 and a 2 by 1. Let's try that. So number 9. 5, negative 3, 2, negative 4, negative 3, 10. All right. Okay. So this is a 3 by 2 matrix. This is a 2 by 1 matrix. So guys, are you allowed to multiply these together? Yeah, because the 2 matches the 2. So yes, can multiply. The right there. Okay, so these can be multiplied together. Okay. And guys, the product is going to be a what by what matrix? It's be a 3 by 1. A 3 by 1. Okay. So, well, 3 by 1, that's a tall skinny matrix. So maybe I'll make something that's tall skinny. This one like that. Okay. All right. So going across the row in the first one and down the column, second one, and actually, so I want to column in the second one.
Everybody.
Okay, so it's 5 times 1 plus negative 3 times 3. Like that. Second row, 2 times 1 plus negative 4 times 3.
When she gets mad.
Third row, negative 3 times 1
No.
plus 10 times 3. Okay. So say equals, and then clean all this up in my calculator. Let's see, that's 5 minus 9. It should be negative 4, right? 2 minus 12, like negative 10. Negative 3 plus 30, 27. I think that should be the answer.
I think you are.
All right, you guys got that?
Yeah, sort of.
Yeah. All right. Now, let's say I had you guys, how do you guys do it? Even questions, but I skipped number 8. Let's take a look at number 8. Okay, number 8, there's a what by what matrix? What's that first one?
Yeah.
3 by 2. Yeah, so 3 by 2. What's the second one? Also 3 by 2. Here, I'll do this all in the corner right here. Is if you have a 3 by 2 matrix and another 3 by 2 matrix, are you allowed to multiply those together?
Yeah.
No. No.
It's pretty much.
Why not? Because 2 does not equal 3. Therefore, you cannot multiply those. Okay. Like if I find number 8 to you guys, the answer would be no solution. Okay. I think all these other ones work out. 2 by 2, yes. 2 by 2, yes. We got a 2 by 1 and a 1 by 3. Guys, can you multiply 2 by 1 and 1 by 3? Yeah, that'll work. And that should give you a 2 by 3 actually. Why doesn't 8 work? Because a 3 by 2 and a 3 by 2, this 2 does not match this 3. So the number of columns here does not match the number of rows here. Okay, that's great. Okay, I'm gonna do one more with you guys for notes. That's gonna be number 16. Okay, we got a story example. There are a few like these. We got custom t-shirts, sweatshirts, and hoodies. There are probably 5 orders for the shipment, and they need to find the total weight before shipping. The t-shirts weigh 6 ounces. The sweaters weigh 16 ounces. The hoodies weigh 21 ounces. Determine the weight of the package by using matrices. Okay. So looks like we have these 5 different orders. Okay. Okay, so that should be 5 different packages, shouldn't it? 5 different packages. Okay. And each of these orders has different numbers of shirts, sweaters, and hoodies. Okay. So let's see, 5 orders, different numbers of hoodies. Guys, could you create out of that a 5 by 3 matrix, a 5 by 3 matrix? Right. Now, I'm thinking ahead a little bit because I could create a 5 by 3 or a 3 by 5. Okay, but I want to be careful because I know there's only certain ways to multiply these. Okay. And then if you have 3 individual items you're selling, shirts, sweaters, and hoodies, and each of them is associated with a certain weight, could that be like a 3 by 1 matrix? Okay. Is that okay? Okay. And I do see it, this 3 matches those 3, which tells me that's exactly how I wanted to set up. Like if I reverse this or reverse this, I wouldn't be able to multiply these together at all. Also, there's only one way to multiply these: the orders times the weights. I can't do weight times orders because that would never multiply together. Okay? Because the number 1 doesn't show up here. Only these 3 match. So there's only one way to set this up. You guys see it? Because these 3 match. So let's create these. Let's create a 5 by 3. So 5 rows and 3 columns. And then a 3 by 1. So 3 rows and 1 column. And then we should be able to multiply those together. Alright, that's good so far. Okay. So it looks like the 5 rows are going to represent the 5 deliveries, or each team. I might even label these.
Oh, yeah.
We got Southwest, we got Oak Hill, we got Smith Convenience, we got Robbins Daycare, we have O&C Dance. And then each of them gets different numbers of shirts, sweaters, and hoodies.
No, we don't have coffee.
So looking at 14, 8, and 4.
No.
We're looking at 70, 0, and 24.
I'm not going to Detroit. I'm not Batman enough for that place.
34, 6, 6.
Enough for that place either.
12, 5, and 7.
I'm not doing
0, 4, and 38. So the way they even presented this data, I can very conveniently turn it into the only matrix that even would have worked to be able to multiply. Because they could have like reverse the x and y axes and made it all weird. But okay, so it's really nice they laid it out exactly like that. All right, you guys good with all these? So, for example, you guys know O and C dance is going to order 38 hoodies and so on. Right. Now, this 3x1 has to represent the weights of each individual item. So, t-shirts, 6 ounces. Sweaters, 16 ounces. And hoodies, 21 ounces. Okay. And I want you guys to see, before I just go plugging and chugging, why this is actually going to work. Guys, if I take the number of t-shirts and then multiply by the weight per t-shirt, doesn't it give me the total weight of t-shirts going to this one delivery? And then if I move on, remember we're going across the row on the first one, down the column on the second matrix. Okay? If I take the number of sweaters, multiply by the weight per sweater. It gives me the total weight of sweaters. And then the number of hoodies times the weight per hoodie gives me the total weight of hoodies. And all go into that one delivery. You see it? So yeah, I got a 5x3 matrix and a 3x1 matrix. I can multiply these together. So check. Okay. And guys, the final answer is going to be a what by what matrix?
5x1.
A 5x1. So I'll have a 5x1. Okay. Because I have 5 different deliveries. And each of those is going to be one package with some weight. You see how it actually goes together? You need matrices to solve this. Okay. So this would be 14 times 6 plus 8 times 16 plus 4 times 21. Good. Since we've done a few of these so far, and I only got so much space in my paper, I think it'd be better if I just have it all on one page here. So I'm going to do all the calculation in my calculator. Did you guys see what I'm doing? I'm just going across the first matrix and down the second matrix. Okay. So the first package, this is to Southwest Golf, is going to weigh 296 ounces. This is the weight and ounces. Okay. How about Oak Hill? Let's go 70 times 6. So 70 times 6 plus 0 times 16 plus 24 times 21. That's 924 ounces. All right. How about Smith Convenience Store? 34 times 6 plus 16 times, or 6 times 16 plus 6 times 21. That many ounces. How about Robin's Daycare? I got 12 times 6 plus 5 times 16 plus 7 times 21. 299 ounces. And finally, O&C Dance. Got 0 times 6 plus 4 times 16 plus 38 times 21. 860 ounces. And now you have a product matrix to show you the weights of the 5 packages. One more thing before I hang up this recording. I meant to put this detail on here too. You guys know that Alex module 11, which has everything in module 11. That's for extra credit. I'm leaving this one open for a few weeks because Alex only had a few questions related to module 11. But some of those questions did involve multiplying matrices. So if you couldn't solve those last week, they ran into a dead end, then now you also be able to do this as well. All right, guys, double check, make sure your name's on your notes and turn your notes into the gray tray.